talking about total internal reflection, which is also known as TIR in short. It is a special kind of reflection that takes place suddenly while refraction is taking place. So it so happens that if you keep on increasing the angle of incidence beyond a certain value, instead of refraction, TIR starts taking place. Remember, this happens only when the ray of light goes from a denser medium to a rarer medium. Consider the diagram shown here. We have an optically denser medium, that is water, filled in a beaker. We have an optically rarer medium, that is air, and a ray of light is starting from the source, that is O, which is placed inside water. If we consider a ray of light that is going normally, it will go straight without any bending, since this is normal incidence. So the angle of incidence here is 0. If gradually I increase the angle of incidence, say to 10 degrees, slightly higher value, then refraction will take place. The ray of light will go from water to air, and hence it will bend away from the normal along AB. If we increase the angle of incidence slightly further, suppose say 30 degrees, the ray of light incident at C again will get refracted along CD, and it will bend away from the normal as shown, because it is going from water to air. Now suppose if I increase it slightly more and my angle becomes exactly equal to 48 degrees, then this ray of light that is coming at E, instead of undergoing refraction, that is, instead of going into air, it will go along the surface of water. Now it is not leaving the denser medium and going into the rarer medium. It is going along the surface. When it goes along the surface, it is known as grazing emergence. So here it is grazing emergence taking place when the angle of incidence is exactly becoming equal to 48 degrees. I'll tell you why 48 degrees. Now when this ray of light is in grazing emergence, that is, it is going along the surface, you can see here the angle of refraction is becoming 90 degrees. Angle of refraction is the angle between the normal and the refracted ray. So this angle between the normal and the refracted ray is becoming 90 degrees exactly when the angle of incidence becomes equal to 48 degrees. That 48 degrees is known as critical angle for water. 48 degrees is the critical angle for water. So exactly at 48 degrees, angle of incidence equal to 48 degrees, angle of refraction in air becomes equal to 90 degrees. And the ray of light, instead of going out in air, it is going along the surface of water, which is known as grazing emergence. Now, if we slightly increase the angle of incidence more than 48 degrees, the ray of light will bounce back into the denser medium, that is in water. And this phenomenon is known as total internal reflection, because the ray of light is totally reflected inside the denser medium. There is no refraction taking place now. There is no grazing emergence taking place now. There is only reflection taking place from the upper surface of the water. So the ray of light is coming back into the denser medium. This phenomenon is known as total internal reflection. There is no light energy wasted during TIR, unlike in the case of a mirror. We have learned in grade 9 that when a ray of light is reflected from a mirror, some amount of light energy is absorbed or wasted. Here in TIR, no amount of energy is wasted. So C is the critical angle. Here this angle is the critical angle for water, that is equal to 48 degrees. Critical angle is an angle of incidence for which the angle of refraction becomes 90 degrees. So we have an important relationship between the refractive index and critical angle. We are supposed to remember mu is equal to 1 upon sine C. where C is the critical angle. So coming to all the definitions, all the theory that we are supposed to remember. One major thing we are supposed to remember all the critical angles mentioned here. Critical angle for glass is 42 degrees. Critical angle for water is 48 degrees. Critical angle for diamond is 24 degrees. So what do you mean when we say that critical angle for glass is 42 degrees? When I say that, it means that if the angle of incidence becomes more than 42 degrees in glass, the ray of light undergoes total internal reflection. So if I say critical angle of water is 48 degrees, it means that if the angle of incidence becomes more than 48 in water, the ray of light undergoes TIR, total internal reflection. And the same thing can be said for diamond. So the definition of total internal reflection: a phenomenon due to which a ray of light, while traveling from an optically denser medium to an optically rarer medium, gets reflected into the optically denser medium at the interface of separation is called total internal reflection. So we have two conditions for TIR to take place here. First condition: the rays of light must travel from an optically denser medium to an optically rarer medium. Remember, when we understood this diagram, our source of light was here. That means the rays of light are going from denser medium, that is water, to rarer medium, that is air. And number two, the angle of incidence in the denser medium should be greater than the critical angle. Okay, here coming back to the diagram, only when the angle of incidence becomes more than critical angle here, for the last ray, where angle of incidence is more than 48 degrees, only then TIR takes place. So two important conditions for TIR to take place. Here we have the definition of critical angle. The angle of incidence in the denser medium, for which the angle of refraction in the rarer medium is 90 degrees, is called critical angle. So critical angle is an angle of incidence and it is in the denser medium, and the corresponding angle of refraction in the rarer medium will be 90 degrees. We come to few important give reasons that are based on total internal reflection. So looking at the first diagram, we have a beaker that is filled with water. Now if we look at the beaker slightly above the eye level, the lower surface of the water appears to be silvery as shown in the diagram. This is because, first statement, critical angle for water is 48 degrees. So when these rays of light are incident, on air-water interface at an angle more than 48 degrees, they undergo TIR and they enter the eye, and hence the upper surface of water appears to be silvery. It starts shining like a mirror because reflection is taking place. Another example: suppose we take a glass test tube, empty test tube, and we place it in a beaker that is filled with water, and we observe it from above. So an empty test tube held obliquely in water and viewed from the top appears to be silver. Now if you look carefully, the rays of light are incident on air-water interface at an angle of more than 42 degrees. Remember, critical angle for glass is 42, and if you look carefully, the angle of incidence in this case, if I draw a normal here, the angle of incidence will become 45 degrees. Half of 90, that is 45. And 45 is more than 42. So if the ray of light is incident at an angle of more than 42, 45 here in this case, then total internal reflection takes place and the surface of the test tube appears to be silvery. Similarly, bubbles rising up in a fish tank appear to be silvery for the same reason, for exactly the same reason. Also, a crack in a glass pane appears to be silvery. So depending on whatever the denser medium is, we are going to use that critical angle. If I have glass, we shall use critical angle of 42 in our answer. If it is water, we shall use critical angle for 48 in our answer. Now, if we come to diamond, the critical angle for diamond is 24, because of which diamonds appear to sparkle in dark. We should not forget that a diamond has many cuts. It has many surfaces at which refraction can take place. These are all the different cuts of the diamond, which provide many surfaces for refraction to take place. So suppose there is a ray of light that is incident. A ray of light is entering the diamond. If it is entering the diamond at an angle more than 24 degrees, it will undergo TIR at the first surface. It will be totally internally reflected. It will go back into diamond, hit at the other surface, again at an angle more than 24 degrees. Again, TIR takes place. Again, it hits the third surface. And this keeps on happening. And in a way, this whole ray is trapped inside the diamond. And after many multiple TIRs, this ray will escape the diamond. When these multiple TIRs are taking place, every face of the diamond appears to be shining like a mirror, and hence diamonds appear to sparkle in dark. We should remember that the critical of the diamond is very, very small, 24 degrees. So when a ray of light is incident at an angle more than 24 degrees, which is very, very easy, multiple times TIR takes place, and all the surfaces of the diamond appear, all the cuts of the diamond appear to be shining like a mirror, and hence diamonds appear to sparkle in dark. We come to totally reflecting prisms, ray diagrams for totally reflecting prisms, which are right angled isosceles prisms. That is, they have angle of 90, 45, 45. So if we talk about totally reflecting prisms, why are they called so? They are called so because total internal reflection takes place in them. So consider a prism here. We have a prism here. Angle A is 45, angle B is 90, angle C is 45. A ray of light is incident normally on the left hand face AB of the prism. Now when it is hitting surface AC, if we draw the normal, it makes an angle of 45 degrees with the normal. 45 degrees is more than 42 degrees. That is a critical angle for glass, and hence total internal reflection takes place. So the ray does not go like this into air. Actually, ray should escape the prism, but it does not escape the prism. Instead, it will come back into the denser medium, that is glass, and go out straight. In this case, if you look at the deviation of the ray, it is getting deviation through an angle of 45 plus 45, that is equal to 90 degrees. It was coming from the left, now it is escaping from the bottom. And hence we say that the ray of light has been deviated through an angle of 90 degrees. 45 for the angle of incidence, 45 for the angle of reflection, 45 plus 45 gives 90 degrees deviation of the ray. Here, remember again in this case, the ray of light is coming from the left hand side, that is face AB, and TIR is taking place at surface AC. So the surface AC appears like a mirror. Second case, on the right hand side, we consider a ray of light that is coming from the right hand side, that is towards the hypotenuse side of the prism. You can look carefully for deviation through 90, and the second case, that is deviation through 180, that I'm going to explain. In both the cases, the situation of the prism is the same. A is at the top, B 90 left bottom, C 45 right bottom. The only difference is in the ray. Here the ray was coming from left. Now the ray is coming from right towards from the hypotenuse. When the ray of light is incident normally, and I draw a normal here, it makes an angle of 45 degrees with the normal. Hence, 45 degrees, since 45 degrees is more than 42 degrees, that is the critical angle for glass, the ray of light comes back into the prism and now hits another surface. Here again, if we draw the normal, it is incident at an angle of 45 degrees, which is again more than 42 degrees. One more time TIR takes place and the ray of light goes back into the glass and then emerges out normally. If we count the angles, 45 here, 45 here on both sides of the normal. For the second normal, 45 here, 45 here on both sides of the normal, which gives us a total of 180 degrees. And thus, the ray of light has been deviated through 180 degrees. We can draw one more similarly. There is no need to draw 3 rays in the prism. That would make the diagram too crowded. I suggest we should draw only 2 rays to show how TIR is taking place. Now, in this case, when we talk about deviation through 180, total internal reflection is taking place at 2 surfaces, and hence 2 surfaces behave like a mirror. First, TIR is taking place at this surface. So, the surface AB acts like a mirror. Second, total internal reflection takes place at the surface BC. So, BC acts like a mirror. Third case. In the third case, if you look carefully, we can see that the situation of the prism has changed. Now, we have B, that is 90 degree at the top, 45 A on the left, and 45 angle C at the right. Be careful when we are talking about the third case, which is known as erecting prism. In an erecting prism, 90 degree is at the top. We are turning the prism such that 90 comes at the top. This prism is known as an erecting prism because if you look carefully here, the object is upside down, and when we get the image, we get the erect image. So it is flipping the image. Hence, it is known as erecting prism. If we draw the diagram, one ray from Y enters into the prism and bends towards the normal because it is going from rarer to denser medium. It hits here. When we draw the normal, it makes an angle of 45 degrees, which is more than 42. So TIR takes place and the ray goes back into the prism. It hits here and then it bends out and comes here. Refraction takes place at 2 surfaces, this surface and this surface. TIR takes place at one surface, that is at the bottom. Look carefully, the ray from Y, that is from the top, now has come to the bottom. If I draw another ray starting from X, a ray from X comes here, reaches here, hits here, bends towards the normal into the glass, hits the bottom surface. If we draw the normal, it makes an angle of 45 degrees. Again, TIR takes place. It goes back into the prism, hits here. Now it is going from glass to air, so it bends away from the normal and reaches here. The ray which was at the bottom, that is starting from X, has now come at the top. So the top becomes the bottom becomes the top, and hence the image is inverted. So this is known as an erecting prism. An upside down thing becomes erect, an erect object will become upside down. So again, totally reflecting prisms are the prisms in which they are 90, 45, 45 angled prisms in which total internal reflection takes place. We have seen how total internal reflection taking place in these mirrors deviates the ray. In the first case, the ray is deviated through 90 degree. In the second case, the ray is deviated through 180 degrees. In the third case, the image comes out to be inverted. Also in the third case, the bottom surface acts like a mirror because TIR is taking place at the bottom surface. It is important to mention which surface is acting like a mirror when total internal reflection takes place.